right, welcome to our new unit about slope and linear functions. Today we're going to talk about how to find the slope or the rate of change from a table. So notice here we have our x values and we have our y values. Our x values are growing by 1, right? 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5. So this is all growing by 1. As x is growing by 1, what's happening with our y value? Well, from 1 to 3.5, that is a jump of 2.5. And from 3.5 to 6, that's also a jump of 2.5. And from 6 to 8.5, that is a jump of 2.5. So to write my rate of change, that is the same as how much is my y going up by divided by how much is my x going up by. And we'll teach you some terminology later that will better identify that, but my y is what goes on top first. So as my y grows, it's growing 2.5 for every 1 it grows in my x values. So my rate of change is equal to 2.5.
All right, so now we're going to look at this table. So these are our x values and these are our y values. So if we look at our x values, we want to figure out what is our x values changing by. So we start at 0 to 1, so we know they're changing by 1. 1 to 2 is 1, 2 to 3 is 1. So our x values are changing by 1. And now let's look at our y values. 2 to 7, to get from 2 to 7, we have to add 5. To get from 7 to 12, we also have to add 5. And then 12 to 17 is 5, and 17 to 22 is 5. So as we can see, our y values are changing by 5 every time, and our x values are changing by 1. So when we write the slope, or the rate of change, we are going to write it as however y changes over however x changes. So if y changes by 5, we'll have 5 on the top, and then x changes by 1, so we'll have 1 on the bottom. So whenever x is changing by 1, we can really just pay attention to whatever y is, because we know that anything over 1 is just itself. So we can say that our rate of change, or our slope for this table, is 5. Now that we have figured out that slope of this line, or the rate of change of this table, is adding 5 every time, we're going to try to graph this and see what happens. So if we plot these points, we're going to see what this graph will look like. So if we remember how to plot points, again, these are our x values and these are our y values. So if my first point is 0, 2, that means I'm going to go over 0 on my x. So if this is my x-axis, this is my y. I'm going to stay here on this line and go up 2. So this is my first point. My second point, I'm over 1 in my x, and I am up 7 in my y. And these are counting by 2. So 2, 4, 6, 8. So 7 is like right here. So I'll have a point here. And then over 2 in my x, I go up 12. 3, I'm going to go up 17. Now that I have all of these points plotted, we can see that the shape of this graph is a straight line. If we connect these points, we have a straight-ish line. I am human. Okay, so this is called a linear function. When our slope, or our rate of change, is constant, when we are growing by the same number each time, just like we had to add 5 every time, when we are adding the same amount every time or subtracting the same amount every time, our graph is going to create a straight line, or a linear function.
So from the graph that Emma just drew for us, let's try to see if we can find this plus 5 and also that plus 1 in our graph. I take any 2 points on my graph and I make what we call a slope triangle. Slope triangles always have this 90-degree angle here. And so between 2 points, we want to find our change in y values and also our change in x. So in Greek, this is the symbol for d, like we do a capital D like this in English, right? But in Greek, they use this, and delta means change in. So we often mean change in y over change in x is for delta y over delta x. So this is considered our change in y because that is how much growth is happening in my y value. And then this is my change in x because this is how far apart are they horizontally. So if I look here, this starts at 12 and it goes all the way up till 17. So I know that that is a change in y of 5. And change in x here, I go from 2 to 3. And so I know that's a difference or change of 1. So you can kind of see from the table how it's 5 and 1, and then on a graph, how do we get the rise and the run 5 and 1. And we'll show you a few more examples of how to get the slope from a graph. Our change in y is how far apart is our y value. So our y value is 3, and coming down, we hit a y value of 2. So this is a difference of 1. So our change in y here is 1. Okay, and then let's look at our x values. We're here at 0 in our x value, and we're going all the way across until until we hit 3. And so from 0 to 3, that is a difference of 3. So I would say my change in x is 3. Or we write our slope as rise or run. So we'd say our slope for this graph is equal to 1 over 3 because it's our difference in our y divided by our difference in our x.
So in this graph, we already have the change in y right here is labeled for us and change in x right here. So all we have to do is figure out what are those distances. So if we look here, to get from here to here, it's a change of 2 because it goes from 2 to 4. And then my change in x starts at 0 and goes to 4. So it's a change of 4. So I can say that my slope or my change in y over my change in x is going to be 2 over 4. And we can simplify this to 1/2. I can actually draw multiple slope triangles. So I could start here, and instead of going over 4, I could go over 2 and go up 1, just like that. And now I have a new slope triangle with a change in y is 1 and a change in x is 2. So you can draw multiple slope triangles along the same line, and all of the fractions are going to be equal to each other. We could even draw a bigger one, and we could go over 6 up 3. Cut that out, Tiana. I have a change in y of 3 and a change in x of 6. And so now another way we can write that slope is 3 over 6. And all of these fractions are equal to 1/2.
All right, let's find the slope. Given this graph, we got points -2, 4 and 1, 1. We draw our slope triangle. Remember, with our slope triangle, it gives us a 90 degree. We want to find our change in y, aka how far apart are my y values. One thing that's really key to notice here is that this is a negative graph, right? My y values are going down, and because of that, I know my slope has to be negative. So that will come into play as we're finding our y coordinates here. This is at 4, okay? 4 is this top of our y, and our bottom of our y values is 1. So from 1 to 4 is a difference of 3. I have to do 4 minus 3 to get down to 1. So my change in y equals -3 because this starts up at 4 and I drop down to 1. So that's a difference of -3. I'm adding -3. Okay, if I look at my x values, I start here at -2. I'm going all the way across here to +1. And so my x values has the difference of 1, 2, 3. So my change in x is equal to 3. So my slope for this graph is -3 over 3. -3 over 3 is just -1. So I know my m, or my slope, is -1 because I went down 3 over 3, or you could also draw on here that I would go down 1 for every 1 value. Down 1 for every 1, down 1 for every 1. All right, let's find the slope of this graph here. Looks like we're starting at -3. If I try to find my unit rate, it might be a little bit challenging here, right? Like this is over 1, this is distance of 1. But when I go up, I don't know exactly how far up this is for sure. This is like -2.75 or -2.8. Like I'm not sure, you know. And so when you're creating your slope triangles, it's really key to find points where it crosses the grid evenly, where you know for sure it crosses at a whole number. So looking along our graph here, looks like it doesn't hit a nice even spot until here, where it's at 5, -1. So I'm gonna take this and make our nice slope triangle. So our change in y is from -1 down to -3. So that's a distance of 2. My change in x, I go from 0 and I end at 5. So my slope here would be 2 over 5. Some other key features to point out on a graph as well are the x and y intercepts. Our x-intercept is when y is 0. So we have some x value and our y value is 0. When y is 0, where does it cross the x-axis? Okay, it looks like it crosses here at like 7.5. So I would say my x-intercept is 7.5. All right, let's check out our y-intercept. And this is just when x is 0, what is our y value? If I go here, x is 0, what is my y value? Or where does it cross the y-axis? Oh, looks like it crosses here at 0, -3. And so that would be my y-intercept.
All right, so now that we have our slope, let's see if we can write this as a unit rate. And remember, we learned that unit rate is for every time our x changes by 1, how much is our y changing by? Because in this case, x is changing by 5, and then y changes by 2, but we want to figure out if x changes by 1, what does y change by? And to figure that out, all we have to do is just divide our slope. So 2 divided by 5. And if we do 2 divided by 5, we get 0.4. So that tells us that every time we change by 1 in our x, we change by 0.4 in our y. So if we kind of look at it on the graph, if we start at our y-intercept and we go over 1 in our x, that means we're going to go up 0.4 in our y. Over 1 in our x, up 0.4 in our y. So we've represented this linear relationship. First, we saw it in a table, and then we were able to plot the points and see it in a graph and see that it creates this line. And now we want to represent it algebraically in an equation. So if we think about the pieces of what our equation would need to have in it, we start at this -3. That's going to be an important point, okay? So we're just going to have this. And an equation always starts with something is equal to something, okay? So we're going to say y is equal to, meaning we're going to try to figure out what our y value is. Our y value is equal to -3 because that's where it starts, right? That's fair to say that y is equal to -3 right here at this point. But then y isn't always equal to -3. It changes. Here it's equal to -2.6, right? And then it keeps changing. And eventually it's equal up here to -1, okay? So we have y equals -3, and then it's changing by 0.4 every time we change by 1 in our x, okay? So it's adding 0.4 every time we change our x, and that's where this variable x comes from. So we're saying 0.4 times the amount of x's we have, and then we add on this -3, and this will give us this equation. And so let's test some points. Let's test this point right here because this is a nice number. We know that this is 5, -1. So this is our x value and our y value. So let's plug that into this equation and see if it's equal to each other, okay? So if we say that x is equal to 5, we'll have -3 plus 0.4 times 5. Okay, so if we plug in 5 for x and we do 0.4 times 5, plug that in your calculator, you'll get 2. So then we'll have -3 plus 2, and that equals -1, which matches our y value here. So we know that this equation, y equals -3 plus 0.4x, represents this line.